All right, this is the substitution game, and you are hearing the Mario Kart music because we're going to play this game within the context of Mario Kart. And what this is examining is a type of mathematics in advanced algebra called substitution. And what we're going to look at is whether two players in a Mario Kart game would collide if they were actually riding around in a real space, which we will model. So this is a math test, but it can be a game. And in fact, those of you who are interested in programming will find this test very interesting. Creating games or programming games, all that stuff will come in handy when you learn how to do this test. But first, so we need to understand what substitution is and how we're going to use it within the context of this game before we really get into the nitty-gritty of the actual game that we're going to play. So the game won't be any fun unless we know kind of ahead of time what it is we need to do. So we're going to do a quick review of substitution, which is a concept you would have covered in Algebra 1. But you may not have gone as in-depth or combined it in the ways that we're going to in this example. So let's assume for just a moment that we have two linear equations. And let's give those linear equations the y equals 4x plus 2. There's a linear equation. This is in mx plus b form. And let's say we want to find out if and where that equation, the line for that equation when graphed, will intersect or crash into another one. Now let's just make it up. Let's say 10x minus 3. Actually, let's make it plus 3 because I want to see if these equations will in fact cross and where they will cross. So there's our two equations. And you say, well, how do we discover where they cross on a graph? Now, we could graph them and see where they cross, but you know, a lot of times when you, and we will, by the way, when you graph equations on a piece of graphing paper, they might cross in the middle of a square, and you know, you're not entirely sure exactly where that point is. So how do we know precisely where that point is? Well, we do something called substitution. Okay, so here this is going to be substitution. And what we do is we'll solve for one variable, like these are already solved for variable y. Think about it that way. Now I'm going to take one of the solutions for that variable. In this case, it's the equation 10x plus 3, or the expression 10x plus 3, and I'm going to substitute it in for this y right here. Let me just show you how that works. So I'm going to take 10x plus 3 equals 4x plus 2. And now I'm going to solve for x. So let's work through the solution. I want to gather all my x's on the left side and all my numbers on the right side. So I'll start by subtracting 3 here and subtracting 3 here. Okay, that cancels out to 0 on the left, and it leaves me with negative 1 on the right. Okay, let's rewrite our expression. 10x equals 4x minus 1. Remember, I want to get x by itself, so I will now subtract 4x from the left, bringing it to 0. and 4x from the right, bringing it to 6x equals negative 1. I'm not done yet because I need to divide out the 6 on the left and divide out a 6 on the right. That will leave me with x equals negative 1/6. This is a part of a coordinate pair. This is the x value for a coordinate pair for an intersection. So if intersection coordinates where the two lines cross will be represented by a coordinate pair x comma y. And we know that, or we think we know, that one of those coordinates, the x coordinate, is negative 1/6. But the way we find the y coordinate and make sure that this whole thing solves correctly is by substituting this x value of 1/6 back into either of these equations. It doesn't matter which one. We'll do the top one. I just picked it out of thin air. Doesn't matter. So we have y equals 4, and then we're going to replace that x with negative 1/6. So open parentheses, negative 1/6, close parentheses, and then bring down that plus 2. And now we just solve. So y equals negative 4/6 plus 2. That's y. And we can reduce this fraction down to y equals negative 2/3. And now I've got to deal with the plus 2. Now it's important that, because I need to actually add 2 and negative 2/3 together, I've got to put 2 with a denominator of 3. So in other words, I need a number which, when divided by 3, gives me 2. Now can you think of a number? How about 6/3? 6 divided by 3 gives me 2. So 6/3 is the improper fraction with a denominator of 3, common with negative 2/3, where when I divide it out, I'll get 2. So I'm not actually changing the number when I write plus 6/3. You just have to kind of think about it to find that common denominator. Now I can combine these two terms because they both have a common denominator. So minus 2 plus 6 gives me plus 4, so I have 4/3, and that's y. Y equals 4/3. And what is 4/3? Well, it's 3, or rather 1 and 1/3. The improper fraction, 3/3 is 1, and then you're left with 1/3. So you have 1 and 1/3, or 1.333 repeating. We'll write it like this. So my x value up here was minus 1/6, and my y value was 1 and 1/3, or 1.333 repeating forever. So that is the intersection point. Intersection. In the game, this is the point that I call the crash point. So if we imagine the lines as representing Mario Kart carts rather, then they would kind of crash into one another where these two lines meet. And they meet at this coordinate pair right here. Let's actually graph it and see. All right? So before we get out our calculator and check all this, because I'm going to show you how to do this on the calculator, I want to show you how to do it by hand. So let us create a graph, and let's just call this point 0 right here, and this is the y-axis. This point is 0, so we'll draw our x-axis right here. This is the x-axis right here. Okay, it's just an xy graph. Well, now we should probably label our points. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. And then on the x-axis we'll do the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay, so now we're in a place where we can start plotting points. Well, the point that we're hoping our two lines intersect at is at -1/6 on the x-axis, which would put us into the negative territory. So I'll write -1, -2, -3, -4, -5, -6, and then down the y-axis -1, -2, -3, -4, -5, and -6. So what we're saying here is that we think our two lines intersect, or the two karts, as we see in the game, crash at -1/6 x and 1 1/3 y. That would put us somewhere, because -1/6 is very hard to find. It's literally going to be 1/6 of one of these squares. So somewhere like right near the origin on the x-axis, and then I go up to 1 1/3 on the y-axis. So I'm going to go up to 1 1/3, I don't know, about right there on the y-axis. And I'm going to mark that point like a test. You know, it's where I hope this thing passes through. So I'll mark this with a red dot, just so we kind of know that we're headed somewhere in that direction. Well, now let's see if we actually get there. We're going to graph these two lines. So I'm going to transfer these equations to my graph paper. Y equals 4x plus 2, and y equals 10x plus 3. And now we can look at them. Now we say, well, how do we start graphing these linear equations? Well, we have to remember that we always start at the y-intercept. Okay, so we're going to go back a step here and write down what the y-intercepts are. The y-intercept for the top equation is +2. The y-intercept for the bottom equation is +3. And when equations are in mx plus b form, this is called the slope-intercept form. We see the intercept and the slope just jump right off the screen at us. So in this case, the slope, m, is 4, +4. And then for the bottom one, it's 10. Now, quick reminder that slope can be drawn, or it's easy to draw when you think about slope as rise over run. All right, rise over run. And these are both positive slopes, so like for 4, it means we're going to go from the starting at the y-intercept value of 2. Here's the y-intercept for the top equation. I'm going to go up 4, rise 4, and then run to the right 1. And then rise 4, run to the right 1. So let's start at 2 and go up 4. 1, 2, 3, 4. Now run 1. So that is a point for that top equation. Now it's starting there. Let's go up 4 again. 1, 2, 3, 4. Run 1. Let's plot one more point. 1, 2, 3, 4, run 1. Okay, now if I've done this correctly, I'm plotting a straight line, and yes I am. So we have a kind of preliminary confirmation of our thesis, because that line does indeed pass through our test point there, where we hope the other line passes through as well. And we're going to label this curve y equals 4x plus 2. Let's draw the other one. Okay, this one has a much bigger slope. So we're going to have to start at the y-intercept of 3. Let's start at 3. Now we have to go up 10 over 1. So 3. We start here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 1. Okay, now go back down to 3, and we're going to go down 10 and then to the left 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the left 1. So I've got a point right there. All right, so I actually have 3 points plotted on this extremely steep angle. I know that my y-intercept is at 3, so the point's going to pass through there, it's going to hit here, and it's going to hit here. So I take my straight edge and line up all those points very carefully. And hopefully what we see is we see this second line pass right through that test point. I'll draw this one in red. And it looks like math has survived another day. Math works. We will label our line y equals 10x plus 3. Okay, and we see that the intersection does in fact happen exactly where we thought. The intersection is at, just like we computed, the intersection is at -1/6, comma 1 1/3. Okay, so that's your x and your y. That's the intersection point. And it's this game, this is what you'll produce each time you do one of these problems in your game. But this is what's going on in the background. Okay, so let's double check this with a calculator, and I will show you how to kind of do this on the calculator as well, right? So let me turn on my calculator, and I'll just put it center screen. First, I'm going to clear the memory. It's important to clear the memory so we don't have any extraneous data left over in our lists or tables. Now, because I have these in y-intercept form, I'm going to go and put them in 4x plus 2 and 10x plus 3. And just to be super clear, I'm going to, this one's going to be red and this one will be blue. Okay, so what we're hoping is that we see this plot look kind of like this graph right here. All right, well, let's graph it. Okay, and there's the red line. It's a beautiful thing when you see what you did by hand match what happened on the calculator. Now, where is that intersection point? Okay, well, the intersection point can be found by hitting the second key on your calculator and then hit trace. And what you want to find in this menu is intersect. So hit enter, and it says first curve, so we hit enter again, second curve, and we hit enter again, guess, and we hit enter again, and then it gives us the intersection. And it tells us in our calculator that the intersection is minus 0.1667, oh, that just repeats forever, comma 1.333 forever. Okay. Well, do our fractions here actually compute to those numbers? Yes, they do. If you divide these out, if you take negative 1 divided by 6, you'll get minus 1.66666 for forever. And if you divide 4/3 out, you'll get 1.333 forever. So that is a great confirmation of what we did here on paper. The thing is, you must know how to do the substitution using the paper and pencil method. Even if you can confirm your findings later with a calculator, what we're actually testing and teaching is the algebraic solution. All right? Now, in our test, we add one layer of complexity to this. Because it's a game, there has to be some element of chance. So what we're going to do in the game, which we'll now turn to, is we're going to have to use something called the Pointslope Formula. And I suppose I should work a problem where I show how to find using the Pointslope Formula. But in this game, you're going to be asked to find, using a random number generator, you're going to be asked to find the equations of lines. So let's go out of this. Let's clear these out and get out of this entirely. Go back to our home screen. We want to generate random numbers. Now we're just going to do this for 2 lines. So in order to generate 2 lines, I have to have, so for line 1, I need 2 pairs of coordinates. Okay, I need 2 pairs of coordinates for line 1. And we'll call this line 1. And for line 2, I also need 2 pairs of coordinates. In other words, I have to have 2 places where I can put a dot so I can lay down my ruler and draw a line through them. Well, we're going to generate these points using a random number generator. That's the part of the game. And it also teaches you how to do this on the calculator. So on your calculator, you have a math button. Hit the math button and then move your cursor over to probability, or prob, and move down to rand int, because we want these to be integers or whole numbers. So I'm going to hit rand int, enter. Now I'm asked for a lower limit. Well, my lower limit we're going to place at 0, and my upper limit we're going to place at 10. We'll leave in alone, and then we hit paste. Okay, this is hit enter one more time, and it generates a random number. In this case, it generated 10. So we're going to put 10 right here. We're going to run this again. So I'm going to hit up cursor until I've highlighted rand int, and I'm going to run this test again. Now I've got 9. I'm going to put that right here. Okay. Now I'm going to go up and run the test again, and I've got 1. And I'm going to go up and run the test again, and I get 5. And I'll go up and run the test again, and I get 4. And I go up, run the test again, and I get 8. Go up, run the test again, and I get 0. Go up, run the test again, and I get 3. Okay, you might get different random numbers, but these were randomly generated. You know, I had no anticipation that I would get these numbers, but what we have here are x values and y values. All right, so we label these x1, y1, x2, y2, x1, y1, x2, y2. Now we're going to take these lines one at a time. And you'll see how by doing this we'll just end up with two lines in slope-intercept form. And that will dovetail with where we started this video. All right, so we'll put the calculator aside for just a moment. And we're going to look at the point-slope formula. Because when you just have coordinates, you have to use the point-slope formula in order to find the equation of the line. So the point-slope formula says y2 minus y1 equals m for slope x2 minus x1. So we will plug in using, we're going to do line 1 here. This is going to be for line 1. That way we don't get confused. So right now we're only looking at this row of data. Let's plug in y2, 5, minus y1, 9, equals m, which we don't know, and then x2, 1, minus x1, or 10. Okay? So that's what our equation looks like so far, and we're just going to solve first for m. So I have 5 minus 9 is negative 4, equals m, and then 1 minus 10 is negative 9. All right, now I want to solve for m, so I will divide both sides by negative 9. And that cancels out the value there, leaving me, and then these two negatives cancel out to a positive. It's irreducible, so I have 4/9 equals m, or slope. Okay, now we're going to go to the second step of this point-slope formula. So this was kind of part I, and this is part II. Okay, here's the second step. You write a variable y, which we aren't going to replace. We're going to leave it as a variable, minus y1 equals, now plug in what you got for m, 4/9, and then x minus x1. Well, what is the value for y1 and x1? Well, go up here to our coordinate points and we see y1 is 9 and x1 is 10. Okay? Just to be clear, this I usually write as y pound symbol and x pound symbol, because it doesn't matter whether you use these values or these values. I'm going to use the second set of values. So it doesn't matter. You can work the problem using these values as long as you're using x1 and y1 here, or x2 and y2. You can't mix them. You have to choose one coordinate pair and kind of run from there. So let's use these values here. So I'll take y minus y2, 5, equals 4/9, and then x minus x2, which is 1. Okay, and now we are going to solve for y. Solve for y. Okay, so how are we going to do that? Well, we have to get y by itself, but before we can do anything, we have to distribute 4/9 through this parentheses so we can get rid of the parentheses. Remember PEMDAS. First is parentheses. So we'll write y minus 5. Just carry that for a minute. And then 4/9 times x is 4/9 x minus 4/9 times 1. That's just 4/9 minus 4/9. Okay? So the numbers are going to get difficult to work with here in a second, and we'll show you why. Now I need to get this 5 out of the left side and over to the right side because I want to get y by itself. But when I add 5 out of here and I try to put it over here, I'll have a problem because I won't have a common denominator. See, the common denominator here is 9. So I need to get 5 in terms of 9. So what divided by 9 gives 5? The easiest way to think about it is, what's 9 times 5? Well, the answer is 45. 9 times 5 is 45. So what you can do to rewrite 5 in terms of 9 is say y minus 45 ninths. So 45 divided by 9 equals 5. So I haven't changed anything. Okay, equals 4 ninths x minus 4 ninths. All right, so now I'm going to add to both sides 45 ninths, which will get rid of that on the left side of the equation. And on the right side of the equation, I have negative 4 plus 45. So what I end up with is 41 ninths, plus 41 ninths. So I have y by itself now. Y equals 4 ninths x plus 41 ninths. So is this an equation in y equals mx plus b form? Yes, it is. All right, so that is one of our equations. And in our problem that we're given in our test, we're going to do this for both of these equations. Okay, we're going to do this for both of these equations. So we'll just go through this point-slope process again for both of these equations. So I'll try to do that very quickly here and then show you the substitution. So this is going to be line 2. This was line 1, this is line 2. We got to our slope-intercept form of the line down here, which is one of the things we really wanted. Now, for simplicity's sake, and also to teach you something and to speed things along, I'm going to do line 2 using the calculator's slope-intercept function. So let me clear everything out and go to Stat, Edit. All right, so here's what I'm going to do. I'm going to put my x values, which are 4 and 0, into L1, and my y values, which are 8 and 3, into L2. Then I'm going to hit Stat and move my cursor over to Calc and move down to LinReg, linear regression, AX plus B. A stands in for M in this one because TI calculators have to be different. So we're going to hit that. Okay, the X list is L1, the Y list is L2. Enter, 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 and calculate. And what it gives me is, so what it gives me here is A equals 1.25 and B equals 3. Okay, so in order, remember this equals M. So I'm going to find an equation in y equals mx plus b form. Well, I've just circumvented all of this math, which you have to do in your test to show me that you know how to do it. But you can verify your answers very quickly using linear regression on the calculator, stat calc, stat edit, stat calc, linreg. So let's just substitute in these values. Y equals 1.25x plus 3. So is that an equation in slope-intercept form? Yes, it is. So obviously the calculator is faster, but you need to know how to do it both ways. Okay, mathematics is not just a calculator. You've got to know how to do it on the calculator, but this is how you do it the longhand way. And you should know how to do both ways so you can verify yourself. Okay, so now remember we're going to do substitution. So we're just back to like at the beginning of this video. We're going to do substitution. Substitution. To find where these 2 points intersect, if they intersect. Okay, so remember, I've got 2 equations, and I'm going to set them equal to one another, dropping out the y's. And I'm going to solve for x, and then plug that back into one of the equations. So we'll say 1.25x plus 3 equals 4/9 x plus 41 over 9. Okay, so I'm just going to solve for x now. Because we're dealing with fractions that are very lengthy decimals on the right side, over here I've got 1.25. Well, that can be made into a fraction as 1 1/4. Okay, so I'm going to rewrite this 1 1/4, but I can't write it as 1 1/4. I need to write it as an improper fraction. So 1.25 can be written as an improper fraction of 5/4 x plus 3 equals 4/9 x plus 41 over 9. Okay? Well, now I can find common denominators and combine terms and everything. So first, I need to put 3 in terms of 9. Well, 27 divided by 3 gives 3. Or sorry, 27 divided by 3 gives 9, which is good. So I want a number which when divided by 9 gives 3. So 27 divided by 9 gives 3. So I can write 27 over 9 in place of 3. So we'll make sure we do that. But over here, look at 5/4 and 4/9, because these are the x terms. I need to find a common denominator. Well, the only common denominator that I'm aware of, the lowest common, is going to be 36. So what I'm going to do is I'm going to multiply, let's show these intermediate steps, 5/4 multiplied by 9/9, okay, plus 3 over 1 multiplied by, remember, we want to turn this thing into where it divides out to be 3 but has a denominator of 9. So what am I going to multiply this by? I'm going to multiply it by 9/9 equals, now 4/9 needs to be modified to be 36. So I've got, this is going to be x. Don't forget to put the x right there. Almost forgot it. 4/9 multiplied by 4/4 x plus 41 over 9. It looks complicated, but it's really not. 5 times 9 is 45 over 36 x plus 27 over 9 equals, 4 times 4 is 16 over 36 x plus 41 over 9. Okay, so even though we have what looks like a messy, complicated bunch of fractions, we have common denominators where we need them, so adding and subtracting will be easy. So now I want to get x by itself. All right? So in order to do that, I will move this term over here. So I'll subtract 27/9 from the left and subtract 27/9 from the right. That gives me 0. And 41 minus 27. Let's rely on the calculator for a minute. 41 minus 27 gives me 14. This gives me 14/9. Okay, so now I'm going to rewrite my expression. 45 over 36x equals 16 over 36x plus 14/9. We're close. So I need to subtract 16/36 from the right side and the left side. And on the right side, that goes to 0. and then I subtract out 16 over 36x here, and I'm left with, now I have to do 45 minus 16, 29 36ths x equals, then you bring down this term, 14 over 9. So I'm almost done, but I have to divide out, in order to get x by itself, I have to divide 29 over 36 by 29 over 36 on the left and right. And the way we divide things out when they're fractions is we multiply that fraction by its reciprocal. So 29 over 36 multiplied by 36 over 29. And the 36's cancel, the 29's cancel, that goes away. Now on the right hand side we multiply by 36 over 29. We actually have to multiply this out now. So now we have x by itself, and we just have to do 14, can't see that because of the glare, 14 times 36 equals 504 over 9 times 29, which is 261. Okay, so now we can actually divide, take 504 divided by 261, and we see that we actually have a fraction, and we'll just approximate that fraction to 2 decimal places. So this as a decimal is 1.93. So we now have our x value. So now all we have to do is plug 1.93 back into one of our equations to find the y value. So let's stick with it, folks. I know that it seems like a lot of mechanics, but let's stick with it. Plug in to find y. All right, so let's take our equation up here. This looked pretty simple. 1.25x plus 3. Plug in to find y. So y equals 1.25, and then replace x with our 1.93 number. 1.25 times 1.93 plus 3. Okay, so it's really just a matter of multiplying the stuff out. So we'll take 1.25 times 1.93, get that, and then add 3 to that number. And we see that y equals 5.4125, okay, which we'll just round to 5.41. So my x and y coordinates, or my intersection, my crash point for this one, intersection, is an x and y coordinate, and the x coordinate is 1.93, and the y coordinate is 5.41. Okay? If we were to go back to our graph here and try to just check that point, 1.93 and 5.41, that would be like 1.93 would be over here, and then 5.41 would be somewhere up here. So like that point would fall kind of like right there where that little dot was. Now I'm not going to plot these lines, but I could do this. I could plot these points by hand. We'll just do it in the calculator and save time. So put in 4/9 x. If you hit math and go over to frac, you can enter the fraction 4/9 and then put x plus, and then another fraction, 41 over 9. Now that's one of your equations. And then your second one is just 1.25x plus 3. Now graph those two and see if they intersect at 1.93, 5.41. Okay, let's check. So we hit second, calc, and then go down to intersect. First curve, enter. Second curve, enter. guess, enter, and intersection. And if you look closely, it says the intersection is 1, I see that's just getting blurry, 1.93 for X and 5.41 for Y. A wonderful confirmation of what our guess was. I mean, what we came up with. And this is the crash point in the math test that we're doing. This is the crash point. So now you've been given, as we enter this substitution game, I don't want to give you all the answers to this, but I have taught you in this tutorial every step that you need in order to complete three plays of this game. Okay, you're going to complete 3 plays of this game and just fill in the data as you find it. So refer back to this tutorial in order to solve the intermittent problems that you encounter as you do this assignment. All right, so I hope that was helpful, and we will finish things off with a little bit more of Mario music here.